That's where the voice comes in. That's where wearables comes in. That's where remote EEG monitoring, brain activity comes in. And all of these different measurements give us a composite of how somebody's doing in their journey of mild cognitive impairment and ultimately allows us to find new treatments.
Alzheimer's disease is a tough diagnosis for both patients and families, and rates of the brain disorder have been rising worldwide. Researchers have been working for decades to understand how to detect, prevent, and treat all aspects of Alzheimer's disease, and we're starting to find some of the answers. That's ahead on this episode of Tomorrow's Cure, a podcast from Mayo Clinic that brings the future of medicine to the present. I'm Kathy Wurzer. Thanks so much for being with us. Today, we're speaking with three experts who are working to keep Alzheimer's at bay. Dr. Vijay Shah is Executive Dean of Research at Mayo Clinic. He works with Heidi Dieter, the Chief Research Officer at Mayo Clinic, and together they supervise all research across Mayo Clinic as a whole. Dr. Shah has been at Mayo since 1999. He's an expert in chronic liver disease. Heidi is a layperson. He talks about the science. She translates it so everybody can understand. I'm so honored that Amy Goldman is with us. She's the CEO and chair of GHR Foundation. That's an organization dedicated to building a future free from Alzheimer's. GHR stands for Gerald and Henrietta Rowenhorst Foundation. That's Amy's parents. Amy, welcome to the program.
Thank you, Kathy. Great to be with all of you.
I think we should maybe start on a personal level here. There was a recent survey that shows there are more than 7 million Americans living with Alzheimer's. And as you know, there's a ripple effect from the person with the disease to their caregivers, to their friends and family. And Amy, I'm going to begin with you. How has the disease touched you personally, you and your family?
Well, Kathy, my mother died with Alzheimer's. She was initially showing symptoms of memory loss in her very early 60s and lived really for 22 years after that with the disease and with the continued decline.
That's a long time, Amy.
It was a long time, and it certainly, as you say, the ripple effect out to our entire family and community was awful. There's no other way to describe it.
Is that the spur for your work?
Yes, it is. Having that personal experience and understanding really has created a commitment to preventing Alzheimer's so other families don't need to go through this.
I think Dr. Shah and Heidi, if you have a personal story, would you like to share it with us?
Sure, Kathy, I'm happy to share. Although not diagnosed officially with Alzheimer's, my dad has been struggling with cognitive decline for, probably the last decade at least. And he is the one who first came to us and said, I think I have Alzheimer's. And we had him checked out at Mayo Clinic, and they are following him very closely. He's in the study for aging, and so far, no official diagnosis, but certainly struggling with the cognitive decline year after year.
There are so many people skittish about early detection and diagnosis. I think because there's no cure at this point for Alzheimer's. There are still some misperceptions about the disease and other dementias. There's still some community and family stigma associated with an Alzheimer's diagnosis. Given all that, why do you think early interception is important? Dr. Shah?
Well, I think that once you know what's going on, you can do something to mitigate it. So, for example, when my father had cognitive impairment, even at the earliest stages, knowing that allowed us to do some really simple things like making lists. So, even simple things like that, watching what route you're going to walk a certain way and then doing the same route over and over each time. There's little hooks and tricks that just make life easier if you know what's going on.
In addition, Kathy, there are therapies either already approved by the FDA or that are coming that can address aspects of the disease. And so to be able to diagnose early, really before symptoms set in, is increasingly being shown as very important to intervene. And the example that I think is very relevant is if someone has a proclivity towards heart disease and they have high cholesterol, they can take a statin. Now, they don't wait to have a heart attack to take the statin. They take it as a preventative. And we really want to get there with Alzheimer's disease as well. And that's why early detection really will matter.
Interesting progress in the ways to detect the disease. There was a brief mention of the study on aging that's being done at Mayo. And I know studies are being done on biomarkers in spinal fluid and blood that could indicate some early changes in Alzheimer's. Heidi, do you want to maybe tell us a little bit more about that?
Yeah, I'll tell you a little bit about the long-term goals are really to develop tools that help predict and prevent cognitive decline and dementia. Also developing risk prediction models for cognitive impairment. And so we have a large cohort of patients that are enrolled on a regular basis to continue to add to the richness of the data within this study.
And what's incredible about the study is if I go back in the mists of time, way back when it was really first starting, there wasn't there wasn't a goal, so to speak. It was really just to capture the data, capturing samples. And it's expanded now. Our funding has helped expand the participants in it to be younger, to be geographically dispersed. So we also now include work in Jackson, Mississippi. And to have the set of samples that then became data that now has been used to really help with the definition of what Alzheimer's disease is. We are very pleased that within the study, that's now a way to use blood diagnostics to really test and understand what's happening within a broad cross section of people who are enrolled in the study. So the blood tests are really shown to be as accurate as the gold standard to date, which is a PET scan. And they're much less expensive, obviously less invasive than a spinal tap. So we really are extremely enthusiastic and optimistic about the role of blood tests in diagnosing Alzheimer's.
I want to talk about one of the ways we're thinking about detecting that can get us to even more scale, and that's voice. So, right now, we know that if we want a blood based test, we're not actually able to do that at a population level in an instantaneous way. So, one of the areas we're working at through the Center on Aging and the neurology teams at Mayo Clinic is voice biomarkers. So, in fact, you can imagine that depending on the day and how you're feeling, your voice sounds different. And you can imagine that each day, if you gave a sample of your voice, that over the years, if you are starting to have mild cognitive impairment, that your voice is going to start sounding different. And as an individual, it may not be so useful on its own, but when we take voice recordings from millions and millions of people and put it into an AI model, it starts to allow us to identify changes in voice that are predictive of mild cognitive impairment. So that's the type of a biomarker that we can scale because even Heidi and myself, we both have apps on our phone that allow us to deposit voice data every day for the Mayo Clinic investigators to be able to detect serious and complex disease before it happens.
Heidi, as a person I work with my voice every day of the week, and I'm wondering how in the world, who discovered this potentiality as a biomarker? And what are you looking for? A warble in the voice?
So we have many teams at Mayo that are looking at this right now as a possibility and to see what they can gather in terms of insights from the information they're gathering from people like Dr. Shaw and I as we once a month speak into our phone, say the vowels. It takes about 5 seconds, and then we're done. So we don't know yet what that will determine, Kathy, but we're imagining that it will unlock the mystery of many different types of diseases. So at this point, we're just interested in getting as many people engaged as possible. As you can imagine, the more people that engage in this type of clinical trial, the more opportunity we have to dig into that information and gather insights.
Kathy, I'll just add a few use cases which are quite surprising, actually. Like cognitive impairment, you can almost imagine where somebody's voice would change. Again, when we each of us gave our story, we can imagine a loved one whose voice was changing as they had cognitive impairment. But in fact, voice can also predict heart disease. Voice can predict liver disease. Those are some studies we're involved in. And the important thing is the voice changes occur much earlier than you might find through traditional signs and symptoms of the disease. And that's really, as we discussed earlier, the early detection that's so powerful, and the non invasive nature and scalability of the approach.
A hallmark of Alzheimer's involves proteins that start building up in the brain, kind of gums up the neurons in a sense, as many as 10 years before the first symptoms appear. And we were, of course, talking about biomarkers. Amy, could you tell me a little bit more about how GHR has made investments in supporting developments in testing specifically for the tau tangle pathology?
Yes, and we're seeing that there is a progression in Alzheimer's disease where the amyloid plaque builds up and then leads to the tau tangles. And so we are also working with a partner with Mayo on developing a blood diagnostic around being able to test for both so that the treatment can then be more comprehensive.
And Dr. Shaw, what do you know about this?
Well, I think that, Kathy, one of the tenets of the pathobiology is understanding what's happening in the tissue. But then now with AI and our newer technologies, we have the opportunity to digitize that tissue and then find non invasive approaches to be able to detect what's going on in that tissue. For example, certainly in the brain, it's a very difficult place to get tissue for analysis. And so then it follows that we would have radiographic markers or blood based markers. And this is the approach that we're taking with digitized pathology, is being able to predict what kind of digital signals we might see from non-pathologic approaches. So that might be from blood tests, it might be from radiographic tests, and it might be from other non-invasive approaches. So again, the power of AI to be able to make causal inference about what you might see in the pathology of an organ by non-pathology approaches.
So, we all know that Alzheimer's is a heartbreaking diagnosis. And I'm wondering about the genetics of it. What are we learning about the genetic underpinnings of Alzheimer's, especially around early onset? What do we know? Amy?
Well, again, it's an area where we're continuing to learn and the learning is accelerated. But I can tell you a specific example of another research platform that we support, which is called the Diane Trials Unit. And Diane stands for dominantly inherited Alzheimer's, and it's a network. And it's families that have this genetic mutation where they develop Alzheimer's very, very early and usually die in their 40s. There's a very courageous set of these families with this genetic mutation who have become participants in studies on prevention. And so there are trials that are starting at a very early age with members of this trial unit who we know will develop Alzheimer's but have no symptoms yet. So it's yet another area, Kathy, where knowing that they have the genetic mutation and they will develop Alzheimer's is really helping advance the science for all of us, whether we have a genetic mutation or not. There are other genetic profiles, like the ApoE4 gene, which shows a proclivity to having Alzheimer's more in the general population. And that's something you could go to Mayo Clinic now and get tested to see if you have it. And again, it's just showing some of these advances in the individualized medicine and the genetic testing that's available to all of us in a clinical setting.
Alzheimer's is a polygenic disease. So many genes contribute to Alzheimer's. So when we think of something like sickle cell, that's one gene edit can correct the disease, right? And you're seeing that now with CRISPR therapies. Polygenic diseases, we would have to do many edits to correct the disease. And we will get there. I think in 10 years, 5 to 10 years, we'll be in a position where we'll be able to do multiple gene edits. But with polygenic diseases, it might not even be just a couple few. It could be many gene edits, right? So, but the first step is to be able to detect all those genes that are altered in that disease state. And that's done through high throughput sequencing. And it brings us to one of the initiatives we're working on at Mayo Clinic, which is called Precure. And within Precure, one of the areas we're focused on is Alzheimer's and cognitive impairment. And we'll be enrolling many patients prospectively into this study and doing a number of different analyses to try to be able to detect disease early and then to be able to assess disease progression over time. The focus will be on looking at gene mutations, so high throughput sequencing, in lots of patients, and then also looking at their environment. And that's where the voice that we discussed comes in. That's where wearables comes in. That's where remote EEG monitoring of brain activity comes in. And all of these different measurements give us a composite of how somebody's doing in their journey of mild cognitive impairment and ultimately allows us to find new treatments.
Now, Heidi, Precure, it's not prevention. You're getting ahead of the disease even before it blossoms, in a sense, right?
That's the idea, Kathy, is how do we go way upstream with people before they ever become patients? So far before they even receive any symptoms, is there something the body can tell us or clue us into that would leave us to believe that they might develop something in the future?
Amy, as a person who is deeply embedded in this work, what do you think? How do you feel when you hear about something like the concept of Precure?
Oh, it's tremendously exciting, Kathy. It really is, because even the understanding of Alzheimer's has evolved over the last 2 decades from being something that really wasn't able to be diagnosed until someone had passed away and had an autopsy to now the diagnostic potential. And to hear even both from Heidi and Dr. Shaw how close we are to realizing some aspects of that vision, it really is a brave new world in healthcare that's accessible to the public.
It's amazing to think that we might be able to prevent onset of Alzheimer's disease somewhere along the line.
Yes, it is amazing.
As you all know, it takes quite some time when it comes to clinical trials. And I'm wondering, the concept of a digital twin, I think, is quite interesting. How is that being used to further the science?
Yeah. Well, Kathy, the concept of a digital twin hasn't been applied to healthcare before as much as it has in the industrial sector. So let's just say, for example, you want to see what's going to happen with your rocket ship and you're building a new rocket ship. The rocket ships are pretty expensive and they make a mess if you shoot it up in the air and it lands somewhere, right? So then what you're going to do is build a physical simulation, and it might be in a room, and you would see if you had 1/100th of the size of the rocket, what would happen. But that gets pretty expensive. So now, in the industries, what manufacturing, et cetera, there's a focus on digitizing the whole process so that you can see lots of simulations. What if the rocket was 1 pound heavier? What if the engine had 10 more horsepower? How much farther would it go? How do you get it to land in the ocean versus the land? And those are all the digital simulations. So we're worried about a rocket ship. Can you imagine a person? Like, we would really want to know all the simulations in a person before we gave them a therapy. Let's say a patient with Alzheimer's, and let's say we had an option of 3 different interventions for that individual. Wouldn't we want to know if their genetic profile predisposed them to have a better response from one of those 3 than the other 2? Wouldn't we want to know the patient's personal preferences? What's important to them? What side effects are important to them? And wouldn't we want to know all of the statistics about those different therapies and how they might affect, say, men versus women, certain demographic features? So you can see, Kathy, we're working our way into many, many variables. And that's where a digital twin is so powerful because it can look at all of the outcomes that have happened in many people before this individual and then place this individual into that simulation based on their characteristics and all of the data that allows us to predict which of those simulations is most accurate for that individual.
Heidi, any comment on this?
I really liked how Dr. Shaw described it. I would say we have numerous studies that we have done that show that certain drugs will work for certain populations of people and they won't work at all for other populations of people. And wouldn't you want to know that before you were taking a drug that would potentially have very devastating side effects? So the more that we can customize the care that we provide to people, to patients, the better off we all are.
We've been talking about detection, prevention, a little bit of treatment here, and they're all important, right? But I'm wondering, how do researchers and foundations like yours, Amy, decide what you're interested in, where you put your time and your money?
Oh, Kathy, I'll start with saying there are some intangibles that really are important, and that is in values alignment with the partners that you work with. So at GHR, we focus on very, very long term partnerships for transformational change. Preventing Alzheimer's is one of our main priorities. And really having that values alignment with our partners over time matters. And Mayo Clinic is a very good example of that. Secondly, we really looked for the researchers in the field that were doing the cutting edge work. And I'm talking now about 12 to 13 years ago, and formed an advisory board, which includes Dr. Ron Peterson from Mayo Clinic, to look around the corner. What do they see happening in the field? And where can we as a foundation not only make an investment, but leverage other investments? Because we've been talking about research trials and they're still state of the art. We're hearing visions for the future that are very exciting, but at the moment, clinical research trials are what we have to develop therapies. So as a funder, we think about how we can leverage other funding because we're just a small share of what can be a very expensive long-term proposition to get therapies developed to help people. We heard earlier in the podcast, 17 years maybe for a research trial. That's a long-term commitment to get a therapy out there. And we like to think of our funding as being long-term open-ended commitments to get results. And we may get results in taking twists and turns we didn't expect. So it's being able to be open to failures as well as successes and just continuing learning from that.
I can hear your father in your response here, Amy, and here's why. I mean, your dad was a fascinating person. He was a well-known developer in Minnesota and across the country, and he pioneered the design build concept, the model, which gets construction done faster. So it sounds like you're using a little bit of your dad's concept in the GHR Foundation's giving, especially as it relates to Alzheimer's. Am I right?
Yeah, yes, Kathy. And I'm smiling because it's not on our website anymore, but for a while we even described our philanthropy as design build philanthropy. And that really is where you're able to be nimble and innovative and work with others to come up with a better concept. And it's integrated also design build. It was integrating architects and engineers. And we really think of that as our partnership with great research institutes and institutions like Mayo Clinic.
Can you maybe expand, Heidi, as to how important it is to have a partner who is with you for the whole long run here, instead of just parachuting in, giving you money, and then leaving? Walk us through how this works exactly in the best of all situations.
Yeah, thanks, Kathy. I think it's critical. None of this happens in isolation. And it's very important for us to make sure that we're building an ecosystem around diseases like Alzheimer's, where we have, fantastic foundation partners like Amy and her team at GHR, and industry partners, other academic medical centers. We all need to work together. That's how it's going to happen faster for patients everywhere. What I appreciate so much about GHR and Amy's leadership is she's a savvy business leader. So she stays engaged, right? She doesn't give philanthropy and walk away. She wants to know, what progress are you making? She holds us accountable, which we should be. She wants to know what progress we've made, where are we going next? And then she asks the questions, have you thought of, I read this the other day, what are you doing about that? So she keeps us on her toes, which is exactly what we want and need from our partners.
Well, as Heidi talked about building an ecosystem, we can also help with building that ecosystem. We want the researchers we partner with to also be focused on where their talents are driving them and their research. And we can often help with the convenings, the connections, the things that we may have seen, for example, outside of Mayo Clinic that might connect back. So I think as a funder, we have a distinct perch where we can see things across a field. And I think it's our obligation then to make connections, to bring in knowledge that we've seen in other places, because that way we can help build an ecosystem from the distinct perch that we have.
So it sounds like it's a two-way street here.
Absolutely. That's what we think about with partnership. And we really like to think of it as, again, a very, very long-term partnership, because that's the way transformation happens. Transformation happens when there's a failed research trial, when there's a failed avenue of an idea. That is extremely important to have that partnership to keep going, to extract what can be learned from that failure and apply it in the future. This is hard. This research in science, especially in the Alzheimer's field, it's very, very challenging. It has been. So to be able to stick with our partners over time, I think it has helped contribute to the success of where we are today in the field.
And at Mayo Clinic, the way we're thinking about this is through an initiative that we call Genesis. And Genesis is about how we're going to manage end organ function, end organ failure when people's organs aren't working. One of the organs we've focused on is the brain. And so at Mayo Clinic, we think about what puts us in a position to make the best advances in brain health and brain span. Okay. And one of them is our longitudinal patient record. We're so grateful. We've had so many patients at Mayo Clinic, and we monitor all of that information, compile it very carefully so that we can gain insights from all of that longitudinal patient data. Another major asset we have is our tissues. I mentioned that earlier, and we have a bioresource. That bioresource includes tissues that from patients that we've seen for 100 years. So that again provides tremendous insights. And then we think about our people. And within our people, we have groups within neuroscience, neurology, neurosurgery, super talented people. And some of the areas they're really advancing in is AI. They're advancing a lot in bioelectronics. And we have an initiative within the neuro ecosystem at Mayo that's called Bionic. And that's led by our neurosurgeons and our neurologists and our neuroscientists. And they're looking at the full suite of electronic interventions that can help us with brain health. So, for example, if you have a focus or an area, let's just say, in your brain that's causing seizures, how are we going to use a probe that can not just blast the whole area, but identify just the specific cells that are causing that seizure, and then ablate just those cells, right? So that starts to take us from a very gross or large or macro electronic item to a cell-based electronic intervention that can target cell by cell, and that's called optogenetics. So that's an example of some of the advances that our neuro ecosystem is making in brain health.
We have talked about some pretty amazing things here, friends, during this conversation, but I'm wondering, what are the challenges that are most perplexing to you all when you start looking at something so large as Alzheimer's? So I'm wondering, Amy, when you look at all the work that you've done and that you plan to do, what still is out there that you think, this is just a hard nut to crack?
Well, if you had asked me that question 15 years ago, I would have answered understanding the disease process and finding therapies for it. And we are now there. So I do feel, Kathy, that I continue to be fueled by the optimism of how much progress we've made. It's been a field where it's been 2 decades of an overnight success, is how it may feel to Alzheimer's researchers right now. The next decade is looking at the multiple causes of dementia. And Alzheimer's really has been redefined in the field to be much more accurate clinically. And that's also been thanks to a lot of work at Mayo. But now it's looking at all these different types of cognitive decline, vascular being a big part of it too, and just getting a better understanding of the complexity of the disease. And again, we've already been touching on this, but then how to intervene for an individual with a better understanding of what the disease causes are. So that, I would say, is the next area.
Thank you. Dr. Shaw?
When I was in medical school, we knew very little about the brain. We had very few therapies for psychiatric conditions, neurologic conditions. And yet, I think everyone understood that this was the big opportunity around brain health, ways that we could harness neurons and understand how they function, what differentiated them. And over this period of time, it's just been remarkable when you think about the kind of technologies now of brain computer interface that are starting to come to reality, so that individuals who have speech impairments or vision impairments, we can actually get the signal from their brain and evidence it out. And that's just transformative. Those kind of things would have just been a fantasy in the past. So I think that in the next 10 years, the brain will be the place where we'll be seeing the biggest advances in science and impact on patients.
Heidi, what do you think?
I think you asked the question about what is frustrating, and I would say the majority of us work in and around research for the opportunity. There's just so much that we don't know yet, and there's so much potential. And I would say people like Amy and Dr. Shaw, who are in the thick of it, I think they do it because they see a light at the end of the tunnel. And that's what gets me excited about research in general, is that we're making progress and we're making a difference in the lives of people across the world. And so I don't get frustrated by the science. It never is fast enough. It's never in the moment that we need it. But I think some of the advances that we have made recently, where AI and technology is taking us, I think we'll see that time frame of 17 years speed up tremendously.
Amy, I started with you. I'm going to end with you. What's your dream when it comes to the ultimate goal of this work that you're doing?
My dream really is that we're able to prevent Alzheimer's and related dementias because, again, as I've been saying, we understand now that there are a lot of other affiliated afflictions that people are suffering from. And I think if we can get to that spot where not only we have the therapies or the ability to diagnose, but that it's accessible around the world, and that we've been able to be a small part of that transformation, Kathy.
I wonder what your mom would think of what you're doing. You ever think of that?
I hope she'd be proud, but she'd probably show me in ways rather than say it out loud. And I feel like she does sometimes, Kathy, even though she's no longer here on this earth.
Understand. It has been a real pleasure talking to all three of you. I've enjoyed the conversation. It's exciting, the work that's been done, and I'm curious to see what it will all turn out to be in the years ahead. I appreciate your time. Thank you so much.
Thank you,
Oh,
Kathy.
thank you, Kathy.
Thank you, Kathy.
Tomorrow's Cure is a co-production of Mayo Clinic and PRX. Our producers are Deborah Balthazar and David Newtown. The show is edited by Genevieve Sponsler. Our sound engineer is Tommy Bazarian. Our theme was composed and produced by Terrence Bernardo. Tony Carlson is our production manager, and our executive producer is Jocelyn Gonzalez. The Mayo Clinic production team includes Pui Hong Ang, Margaret Shepard, Samantha Clarkson, Kara Mangold, Felipe Sosa, Kim Ona, and Bryn Sankey. Special thanks to Preston Spire for audiovisual production support. Be sure to follow Tomorrow's Cure wherever you get your podcasts. I'm your host, Kathy Wurzer. Thank you so much for listening.